Practice problem number 1 asks us which statements below are true, and we're told that we're going to need to select 3 correct answers. So as you're reading carefully, this 3 correct answers becomes an important piece. So I know at the end of the day I'm going to need to find 3 correct with 6 choices. There's actually going to be 3 right and 3 of them are wrong. All of this is based on the definition of a rational number, so we're going to review that real quickly. A rational number is any number that can be written as a ratio. We see that rational has ratio right in the beginning of it. Any number we can write as a ratio of 2 integers is rational. So if we know that a ratio is a fraction, we can also just think about this as any number we can kind of write as a fraction. So part A says all integers are rational numbers. I have on my whiteboard here a bunch of integers listed, and I know every integer, every whole number, can be rewritten as a fraction if I just put it over 1. So because every integer can pretty quickly and easily be rewritten as a fraction, as a ratio of 2 integers, I know any whole number is definitely going to be rational. So this is a true statement. Part B says all negative numbers are irrational. And if I take a look at the whiteboard here again, we actually have a negative integer, negative 10. And negative 10 over 1 would be a rational number. So that's one example of why part B, or answer choice B, is false. Answer choice C says all fractions are irrational numbers. That one's certainly going to be wrong if we know ratios. Rational numbers are about being able to write a number as a fraction. The opposite is in fact true. All fractions are actually rational numbers. All square roots are irrational numbers. We talked about this in our discussion earlier. Some square roots, like the square root of 25 or the square root of 100, could actually be rational numbers because they just equal integers. And these square roots that equal integers are rational numbers. So to claim that all square roots are irrational numbers is definitely a false statement because we know at least some square roots are rational. If we've done our work correct, if we're thinking critically, it's just select all 3 correct answers. We know B, C, and D are wrong. Before we read E and F, we should be expecting them to be correct, to be true. E is true because pi is an example of an irrational number. That's the classic example of an irrational number. It keeps going and going and going. If we were to write pi, or try to write pi, at some point we'd have to use this ... symbol, which shows us that it keeps going, it doesn't have a pattern, and those are the types of numbers that are irrational because we cannot write them as fractions. We don't know how they end, we don't know what their pattern is. Part F says some square roots are irrational numbers. We know that needs to be true as well. Some square roots are irrational numbers. We saw 2 examples here on the whiteboard of rational number square roots, but then there's other square roots, the square root of 2 being the prime example, but there are tons of them. If I do the square root of 2 on a calculator, hit this answer here, 1.4142. And so this is my proof here that some square roots are rational, but other square roots, the non-perfect square roots, are irrational numbers. They create these non-repeating decimals, kind of like pi.